Nice. So hopefully you've all already gone through the problem. Let's look at number 4. First part is asking, what is the probability A1 equals 1? What this means in English is, what is the probability that the first item in our sample, or first post, comes from Alan? Well, if you think of our sample as drawing from a bag of 20,000 marbles and each one has a different name associated, probability of drawing an Allen marble is however many Allen marbles are available, which is 500, divided by the total number of posts available, which is 20,000. Part 2 is asking expected value of S1. Well, S1 can either be 1 or 0, so let's, using the formula for expectation, let's and using the same logic as above, the probability that we draw an S marble is just number of S marbles, which is 1,800. Oh, that's a lot of posts. Divided by total number of posts. Now part 3 is just trying to trick you. It's asking expected value of M100. The fact that this is 100 and not, like, that you're looking at the 100th item in your sample and not the first item in your sample is irrelevant, because if you look at the sample design, we're drawing with replacement. That means that the probability of pulling a Manana post on your first draw is the same as getting a Manana post on your 100th draw, because it's with replacement. So as we saw earlier, the expected value of a random variable that takes on a 0 or 1 is just the probability of getting a 1. And just like above, this is number of Manana posts available, which is 700 divided by total. Okay. So part 4 is asking about the variance of D50. Now, we know that regardless of where in the sample we are, D equals 1 with some probability and 0 with P, 1 minus P, so that these sum to 1. This looks a lot like a Bernoulli P variable, and if you remember, we calculated the variance of that and found it was P times 1 minus P, so and what is the probability that D equals 1 on any given draw? Well, it's probability of drawing a Daniel post from the 20,000 available, which is, let's see, 2,000. There you go. So part 5 is asking us to compute the sum well, let's just look at what each variable could equal. If the 400th element in your sample came from Daniel, then this would equal 1, and it would equal 0 else. If it came from Alan, it'd equal 1 and 0 else. And same applies to all, because all these other variables, because we define them in the same way. Now, we're looking at the 400th element in the sample, and you know that that post had to have come from someone. And we're looking at all the possible people that post could have come from. Therefore, you know that one of these has to equal 1. And let's say if the post came, if D equals 1 and the post came from Daniel, then you know it didn't come from Alan or Manana or anyone else. So then you know the other ones are 0. So you know that this is the sum of, like, one of these is 1 and the rest are 0. So That means the sum is 1. So for 4b, the first part is asking to find the expectation of NA, and they define NA equals the sum 1 to 500 AI. Now, because of linearity of expectation, you know that you can just distribute the sum, because the expectation of the sum of a bunch of random variables equals the sum of each random variable. Expectation of AI, well, we talked about earlier how expectation of a indicator random variable is just the probability equals 1. So let's just and from part A, we know that that equals probability of drawing an Allen post is 500. And since you're just summing a constant 500 times, you don't need the sum notation. You know, we're just multiplying or doing this 500 times. And there you go. So for part 2, we're looking at variance of the sum of D. Well, let's think what each of these quantities represent. And D equals 100. So this represents the number of posts made by Daniel in that 500 post sample, and you're summing the contributions of each person to this 500 sample across all the people who could have contributed. So combined, you know the contributions of each person to this 500 sample has to equal 500 because no one else could have contributed. We've captured all the contributors to this Piazza post. So we know that sum equals 500. So we're looking at the variance of 500. Now, what is the variance of a constant? It is 0 because it doesn't really make sense for a constant doesn't have variance. It doesn't vary. It is one single number, and so therefore it varies by 0. Part C. Take a sample with replacement of 20 contributions. What is the probability that 7 were by Daniel? Well, since we're sampling with replacement, we know that these are independent draws because drawing a post by Daniel on the first doesn't change the probability of drawing a post by Daniel on the second. And since we're summing 20 independent Bernoulli trials, if you remember from earlier, that is represented by a binomial distribution. And here, how many trials do we have? Well, we're sampling 20 times. And probability of success, which here is choosing a post by Daniel, would be 2,000, 20,000. And we're looking at the probability that this binomial variable equals 7. So we can call this x, so p. And if you remember for the formula for the binomial distribution, it's n choose x times probability. Let's simplify this to 1/10 to the 7th, and then 1 minus 1/10 to the 20 minus 7, which is 13. This is probability of drawing 13 others. So for 4D, we're looking at probability that in a sample of 10 drawn with replacement, so we know they're independent trials, what is the probability that 3 are from Daniel, 3 are from Serge, and 4 are from Manana? Well, this definitely sounds like a multinomial distribution because we have more than 2 categories and they're independent draws. So probability 3 from Daniel, you remember the formula from earlier, we're looking at 10 trials, 10 draws. We choose 3, 3, and 4. Probability of choosing a Daniel is what we can use above. It's 1/10. Search. And Manana is, how many did she have? 700. Oops, got cut off. Yeah, there you go.